Good afternoon. We are Up and Up. My name is Chase Cowart. I'm an active duty Air Force officer stationed at Eglin Air Force Base down here in sunny, warm, not snowy Florida, and I currently work as a bioenvironmental engineer.
Good afternoon. I'm Brian Gentz. I'm currently located in upstate New York and just separated from the Navy as an E2C Naval Flight Officer.
Good afternoon. My name is Ian Robertson. I'm a retired Air Force veteran, currently living in Colorado Springs, Colorado.
Hi, I'm Kenneth Bailey. I'm an Air Force veteran of 15 years, last serving as a chaplain and currently living in Chicago. There's no shortage of apartment and home finders out there. Zillow, HotPads, apartments.com, rent.com, and all of them let you search for your new home by things like price, number of rooms, type of dwelling, or if they allow pets. But do these factors really help you know where you want to live? Introducing Up and Up, the app that breaks the social norm by recommending the ideal neighborhood for you. Maybe you're a hardcore foodie, and your perfect neighborhood is a slew of restaurants all within walking distance. Or maybe you value the outdoors and want an easy access to parks and dedicated space for biking. Up and Up allows you to select the things that matter most and will provide a personalized recommendation for you. We begin with the homepage, which uses geolocation to play a video of the closest metropolitan city to me. A new opportunity just opened up in Chicago, so let's find my perfect neighborhood. From here, I get a default rendering of all the neighborhoods of Chicago, based on every criteria being ranked equally. I can see what neighborhoods are best suited to me with a quick color representation. Not surprisingly, the loop shows up as an ideal initial neighborhood. When I click on the loop, I can see a breakdown of each of the factors that help rank that neighborhood. For now, the order is just based on the values, but the ordering will adjust to focus first on the factors that are most important to me. Now, I love food, and I always wanted to try this Chicago deep dish pizza I hear so much about. So restaurants, they're important to me. And you know what? I'm a complicated person. So let's see what else I can customize. Oh yeah, love biking, definitely important. I'm gonna max that and maybe I'll lower restaurants to only somewhat important. Perfect, let's build this. As I continue to refine my customizations, the map recalculates the neighborhoods to see what's most important to me. I can see that each neighborhood now shows me all 10 rankings since I chose to use all factors. And I can see that biking is at the top of the list, followed by restaurants. If the main map isn't to my liking, I can also view my personalized rankings as cards. The neighborhoods presented to me in this view are those which Up and Up deems to have the highest level of matching for me. Let's take a look at under the hood to understand how all of this is generated. Ian, can you walk us through some of the back-end engineering?
Yeah, thanks, Ken. There's certainly no shortage of publicly available data, and collecting the right kinds of data is critical in establishing accurate insights. Our collection strategy focused on utilizing multiple data points to increase the reliability of our predictions. Once we established the optimal data sets to compile, we began cleaning the data. As the data science saying goes, bad data returns bad results. Though the multi-source data was highly accurate, it contained more information than we were looking to process. So we began cleaning the data, standardizing the data formats, and removing entries that were irrelevant or duplicated. In order to ensure a high degree of accuracy, we dedicated a significant amount of time toward cleaning the data. We performed feature engineering on the cleaned data, specifically multidimensional reduction, in order to train the machine learning model. And now I'll pass it over to Chase, who will elaborate on the machine learning aspect. Chase?
Thanks, Ian. To better understand what's going on behind the scenes, let's take a look at an example. Here we have Chicago's Logan Square, which, although highly rated in many categories, isn't tagged with the darkest green on the map. We take the scores from each neighborhood in the city we're looking at and transform them based on the user's submitted preferences. This gives us a representation of the score that emphasizes the components they care about and understates those they don't. These transformed scores are then used to compute an overall score for each neighborhood and are compared across the city. We decided to reduce the dimensionality of the problem because in 10 dimensions, it's not intuitive to understand the structure and distribution of the data and how it might change from city to city. Reducing the dimensions allowed for easier interpretation of results, translated to more transparent and representative categorical rankings. The clustering algorithm we used finds groupings of points that are most similar in score, don't overlap, and are as distant from other groupings as possible. We wanted the ability to assign a ranking that was robust enough to deal with the varied distribution of scores, but wouldn't penalize the neighborhood because there were too many other high scores in the city, the way a simple score ranking might do. The centers of these groupings were then ranked according to their central points, and then these rankings became our categories and colors. So as you can see from our example, Logan Square, when only considering parks and entertainment, it goes from a pretty good fit when no preferences are stated to a perfect fit. And now, Brian is going to take us through how we built these maps.
Thanks, Chase. Using React Leaflet, we applied 2 different layers to the map container. First, we'll add a tile layer that generates the map as the base layer. We all know that neighborhood boundaries aren't as cut and dry as state municipalities make it seem. Neighborhoods change over time. Heck, let's look at Wrigleyville. It's a neighborhood inside of a neighborhood. We were able to capture these detailed neighborhood boundaries by using GeoJSON files provided by Zillow. The GeoJSON layer is then applied on top of the map layer. Within that GeoJSON layer, we are able to dynamically change the colors of the neighborhood based on the user preferences, as well as create a pop-up that shows the category scores with the categories that you selected were most important first. All right, enough with the technical talk. We all know what really makes a neighborhood are the events that go on within it. My anniversary is coming up in July, and last year for our first anniversary, Google told me I was supposed to buy my wife paper, whatever that means. So I handed a piece of paper out of the printer to my wife that said, "Happy anniversary." That didn't go over too well. Using the Ticketmaster API, we provide the users with a list of events going on within the city. Let's see what events are going on towards the end of July. Oh, is that a Harry Styles concert I see? Perfect. My wife loves boy bands. I'm totally going to buy tickets for this. I can quickly be linked over to Ticketmaster's website, already loaded for that event. Now, I'm not from Chicago, and I don't understand what the fuss is with this whole deep dish pizza. So I'm not really sold that Chicago's the right fit for me. Let me see what other cities I'm able to choose from. It's cherry blossom season in Washington, D.C., and free museums beat having to go to a Harry Styles concert any day of the week. Let's check out Washington, D.C. We designed our site with scalability in mind and have applied it to the 10 largest metropolitan cities in the United States. You're not a one-size-fits-most sort of person. You want to be in the right spot right away, not after your first lease is up. Stop letting other sites point you in the wrong direction. You're on the up and up. So the front end of our site was designed using JavaScript with React as our framework, and the maps were generated using React Leaflet library. For the back end, we used Python with the Django framework, and the machine learning was powered by scikit-learn library. And now I'm going to pass it back to Chase, who's going to discuss the challenges we had to face.
Thanks, Brian. So we overcame a number of interesting challenges as a team on this project. Notably, working with geographic data was something no one in the group had experience with, and we really had to understand these data structures and mapping libraries to be able to build out meaningful maps. Additionally, finding neighborhood resolution data was difficult. We started off with only Chicago data, but as we continued to research other sources, we found new options that we quickly folded into our application. The new data sources we used allowed us to scale the application to more cities while maintaining data quality. Both of these challenges pushed our group to move quickly and to find innovative solutions or new libraries that would meet our needs. And now, we'd like to open the floor to questions.